thermal expansion is one of the easiest things in physics, but some students don't know it. Look up, let me teach you. Now, when we talk about thermal expansion, just like you can see, when heat, right, is being, applied to a particular form of length, right? So when we have something like the L1, which is the initial length, right, from here to this point is L1. Now, if you apply it to this particular object, you expect that this thing should expand, right? That means from this point to this point is what? L2, right? Based, you can see, tracing it down. Because some set of, heat has been applied. So there must be an expansion due to temperature, right? So that expansion, that temperature application to this particular object will lead to what? An expansion, right? Just like you can see. So if I ask you what will be the change in L, you can tell me that change in L will be what? L2 minus L1, which is just this place alone, right? Because that is how far this stuff has expanded based on the heat applied. So I don't know why students don't know this, but just look up and let me give you a very good overview of this. So now we have different types, right? Different types of expansion, what we call expansivity. And you must also understand the application of these things. When we talk about, railway, when bridge construction, you observe that when you are moving, there's that space that they will leave for expansion and contraction. You understand? Because if they don't leave that space on bridge construction, it can collapse. So because the engineers, they construct that space in such a way to accommodate any expansion that might happen based on temperature from the sun, right? The heat from the sun on the bridge. So that is one of the applications of thermal expansivity. So now we have different types. Okay, that's what we'll be going into now. Different types. So we'll talk about the linear. Number one, the linear expansivity, the area expansivity, then the volume expansivity. Okay, so now this area expansivity, right, and this is the volume expansivity. So you must understand that means they are talking about when the length expand, when the area expand, when the volume expand. Okay, you must be able to know. Now this volume expansivity is called cubic expansivity. You can also call this volume expansivity, we can call it cubic expansivity. Now let's delve into it so that we don't waste much time. Now when there's expansion like this, that expansivity is a constant, right? And it's giving us this alpha. So I'm dealing with the first one, which is the linear expansivity now. It's constant. It's changing L over L1, changing temperature, or due to the temperature that is being applied. Okay. Now from here, what do you observe? This change in L, just like I explained, is what? Is L2, the final length that happened based on the temperature, minus L1 all over L1 change in what? Temperature, or the temperature that is being applied. So from here, what do you observe? Because there's one question in JAMB that is on this, but just take note of this first. Let me just give you an overview. So that means this is what? Linear expansivity. Then it's due to the change in length, L1, change in temperature. Now, the same way can happen for area expansivity. That means I'll be talking about area expansion in that case. So let's say we have for area expansivity such that we have, and it's noted with beta, which is what? Change in area over A1, then the change in what? Temperature. So for me, I already told you that. So that means beta is what? A2 minus A1 all over what? A1 changing temperature. This is for what? Area expansivity. So this is linear. This is area. Then the last one, which is volume expansivity, is denoted with what? With this sign, right? Which is given to be what? V2 minus V1. Just comparing this. V2 minus V1 all over what? V1 changing temperature. So easy, right? Very easy. Now I'll give you, there's one JAMB question about this. That means this thing that you just see here, this is equation 1, like equation 2, equation 3, based on the expansion, right? So this is for linear expansion, this for area expansion, and this for cubic or volume expansion. Okay. Now, let me give you some of the things that you will need to know here. Now, look at it. Let's say I want to deal with this. I want to do something, some manipulation to it. Now, look at it from here. We already said linear expansivity is what? L2 minus L1. L1 change in temperature. Now, look at it. I want to cross multiply such that I have alpha L1. I'm cross multiplying, change in T equals to L2 minus L1. Now, there's one question in JAMB. That's why I'm doing this. Now, I can take all the L1. You can see that L1 is here. L1 is here. I want to take all the L1 together. Okay. Now, bring this L1 to this side. So that means I have what? Alpha L1 change in temperature. When this one comes here, it becomes plus L1 equals to what? L2. Right? Equals to L2. Now, from here, you can see that I can take, L1 is common. L1 is common. Then L1 becomes, L1 is common. Then alpha change in temperature. I'm coming. Alpha change in temperature plus 1 equals to L2. So that means this is a relationship of L2 to L1. Then you can see that L1 is common. I just brought L1 outside. Then alpha change in temperature. Because L1 is also here. So L1 times this will give this. L1 times this will give this. Then equals to L2. Do you get that? So now let's go to area expansion. So for area expansion, since we already said beta equals to what? A2 minus A1 over A1 change in temperature. That means I can make A1 to come. I can collect all the A. Then I will say beta A1 change in T, when this one comes here, equal to A2 minus A1. I can collect all the A1 together now. So it will be beta A1 change in T. Then this A1 can come here, it becomes plus A1 equals to A2. So the question is, make A2 the subject of the formula. So this is the equation. Make L2 the subject of the formula. Can you see? So the same thing will happen. A1 is common into beta this plus 1. A1 times this will give me this equals to what? A2. This is another question that you must know. That means if I don't want to solve for V, you should know the answer like that. Oh yeah, smart people. That will be what? V1 into gamma change in temperature. I'm just changing because this is A, it will be V1. This is beta, it will be gamma for volume expansion. This is change in temperature, it will be the same. Then plus 1 equals to V2. That is for gamma, that is for cubic or volume expansion. Now, that means you know this. This is another way JAMB can ask you to explain this. But there's one JAMB question that I've seen. Most students used to miss it, but I will tell you. They don't know the relationship between linear expansivity, area expansivity, and cubic expansivity. Now, let me show you. People don't know. Note that beta, it is area expansivity, is what? 2 times alpha. Then gamma is 3 times alpha. Never forget this. Never forget this. If you forget this, don't go and write that exam. Anyways, we've started our operation 7 to 7, where we'll be explaining everything in your JAMB syllabus. Okay, it's 8 hours daily teaching, 2 hours per day for each subject, right? So we'll finish your JAMB syllabus from beginning to the end. 8 hours. I'm inviting about 15 medical students, medical colleagues to teach you with myself. So it's going to be powerful. So if you want to register for it, you send me a DM right now. I'm going to display somewhere around this video, the syllabus that we broke down into 7 days, and also the way to register. So just send me a DM to register. If either you are watching this on TikTok or YouTube, you don't want to miss it. If you have not read anything, maybe perhaps you've been working all the days and all the past months, and all you've read and you want to just cover all the syllabus again. This is not the first edition. We've done it over the years, so this is not the first time. So we are not new to it. Okay, we have a lot of people have registered already, but I'm just showing you now. So send a DM if you want to register. So let's get into it. So now, as you can see, this is for cubic and it's 3 alpha. Absolutely. If you would agree with me that length is absolutely L, that means area will be what? L squared. but volume is what? L cube, abi? So maybe that's why they are just saying, okay, from here I can say it is 3 alpha, and this one is 2 alpha. It's not alpha square, alpha cube, or alpha square. Now the question that they asked, JAMB now asks, what's the relationship between beta and gamma? You know, most students know the relationship between beta and alpha, gamma and alpha, but students don't know the relationship between beta and gamma, and I don't know why, because it's just little manipulation. Yeah, let's do it now. See, since I already know that beta is 2 alpha, I can know alpha now. Since beta is 2 alpha, definitely alpha is what? Divide both sides by 2. So this one will cancel it. Then alpha is what? Beta over 2, right? Since I know that alpha is beta over 2, definitely, I can say gamma is 3. Now, since I've gotten my alpha to be this, I can substitute it here to be what? Beta over 2. This is the answer. It's a JAMB question. Or this question is a JAMB question. So now I want to give you a question now. Now solve this particular question. Given that, calculate the linear expansivity. Calculate the linear expansivity. Drop the answer in the comment section. Calculate the linear expansivity. Given that the change in L is 20 meters, L1 is 5 meters, right? Then the temperature is 20 Kelvin. Calculate alpha. I've already given you the formula. What's the formula? Alpha is what? Change in L over L1, change in temperature. So yeah, so this Kelvin, this, then this is a meter. Then calculate the linear expansivity and drop the answer in the comment section. I'll be checking to see who is correct. So your JAMB is just barely some days from now, so you don't want to miss it. If you have not read anything, if you are struggling reading, if you are struggling doing the whole past question and everything, you can see this is it. We've arranged all the topics right into 7 days: physics, chemistry, biology, math, English, all your 5 subjects, and those are doing 4 combination. But based on the combination, we just adjust it into your combination. So you don't want to miss it. I'll be teaching you back to back 8 hours every day to that exam. Okay, I will see you in class. Send me a DM now to join. See you. Bye.